All right, so in this video, we're going to look at some other uses for factoring. All right, little question types that will pop up. All right, so we're asked to simplify this rational expression. This is one of those things where you can't actually go around canceling stuff, like the 2 and the 10. You can't cancel stuff until they've been factored. Remember, you can only cancel out factors with other factors. So what I need to do is I need to factorize the numerator and denominator here. On the bottom, this one's kind of easy. This is just a GCF. They have a 5 in common, and so I'm going to factor out a 5. The inside would be an x and a minus 2. So I'm just dividing those two by 5. Now on the top, they don't have a GCF, so I'm going to be factoring it, into two linear terms. I got to find two of these that multiply back to this 4x squared. And I'm just going to do the brute force approach. Like it could be a 4x and a 1x, or maybe a 2x and a 2x. I happen to know that it's a 4x and a 1x. And then, so these two numbers right here, they have to multiply to 2. But then at the end of the day, I need to be able to get a negative 9x in the middle. Okay, so the factors of 2 are just 1 and 2, but I cannot put the 2 here because 4 and 2 would have a common factor, and the original problem didn't have a common factor. So I'm not going to put the 2 there. I'm going to put the 2 over here and the 1 there. They're going to be same signs, and they're both negative. Okay. So if you check this, you get a 4x and a 2, that will give you an 8, and then a 1 and an x, that'll give you a 1x. And the idea is 8x and 1x, that's where your 9x comes from. Now, a lot of times whenever you're doing these problems, like whenever I factored the bottom, I got an x minus 2 as a factor. That's usually a pretty good indication that the top will also have an x minus 2. They usually build these problems so that you can cancel stuff like that. All right, I'm going to cancel the x minus 2's. And so my final answer is that 4x minus 1 over 5. That'd be my answer. So for all values of x, like if you plug in the number 7 into this expression, and then you come down here and plug in the number 7, they will evaluate to the same thing. You'll get the exact same answer out of both. All right, this is kind of a tricky question. This is a question like from the ACT that I see a lot. If x minus y is 14 and x plus y is equal to 10, what is the value of x squared minus y squared? So you could treat this like a system of equations where you actually try to solve for x and y, like figure out what x is and what y is, and then use that to answer this expression. But what this is, what you're supposed to recognize here, is the difference of squares. All right, x squared minus y squared, that's literally the difference of squares formula. And up top, you have an x minus y and an x plus y, which is the other half to the difference of squares formula. So what I'm going to do is I'm going to factorize the x squared minus y squared using difference of squares. That is x minus y, x plus y. It's literally the formula for difference of squares. You might look that up. But you could check this, x times x, that's x squared. X times y, that's positive xy. Here you have negative xy, and so they cancel. And then the last bit is negative y squared. All right. We want to know the value of this expression, which is x squared minus y squared. And now I'm just going to do like a simple substitution. X minus y is equal to 14. So I'm going to replace this with a 14. X plus y is equal to 10. So I'll replace that with a 10. And then we're just multiplying these two things. 14 times 10. That's 140. And that's my answer.